Okay.
Okay. What is the main thrust of the design you use to create the music palettes? Could you give us a brief overview of your design?
Well, the design that was used for the Music Palace, in principle, is really the same design that one would use in executing the design for any music studio. I use music as opposed to film and television, where things are done slightly differently and where priorities are slightly different. But on the music side of things, when you approach the design, you approach two facets that you must deal with. You look to come up with a completed product that, on the studio side, that will be comfortable for musicians to work in, and that will achieve the sonic performance that you want to get from those musicians from the studio floor. Not necessarily a sonically neutral room, and not necessarily a room with a certain character, but it takes a lot of conversation with the client to find out what in fact they're after from the performance of that studio floor. And your design is affected by the cubic volume of that room, the area, not only the floor space, but the height of the area that you're going to develop, and affected by the quantity of musicians that the client wants to sit on the floor, as well as the total anticipated sound pressure level that would be generated within a studio with the kind of product or kind of bands that the client would describe to you. So a fair amount of client input is required before beginning a studio design, and I use studio as opposed to control room, as the concepts are somewhat different. I started off by saying the studio is a room where musicians will perform, and they have to be comfortable. You have a bit of a different requirement when you move to the control room. Control room is a music room that is energized by monitors, generally monitors in the playback form or in monitoring what comes off the studio floor through the electronic process. And the electromechanical function of the monitor system, coupled to the environment of the control room, needs to develop an honest sonic resemblance of what is happening on the studio floor. The control room really needs to be a sonically neutral room. That is, a room that does not add bass content to the product that you're listening to. It doesn't take away bass content from the product you listen to. It doesn't, it really has no purpose in life other than to deliver to you through the atmosphere, to your ears, a signal that is honest, based on what's coming from that microphone off the studio floor. And so the design criteria for studio and control room, your initial question, is really a two-part answer. One, the performing room, and one, the analytical room, where answers and conclusions have to be drawn by the producer and the engineer.
Your design uses many different construction techniques. Let us start with the shell of the design, walls, floor, ceilings. What materials are used and how are they applied?
It's a big question. How to briefly approach this. First of all, the shell for the music rooms, control room and for studio, serves a function of dividing the surface area of the two rooms into the most desirable music proportions that will result in a good musical performance on both sides of the glass, and that will yield enough space to be able to accommodate the anticipated usage, the size of the console in the control room, the amount of outboard equipment in the control room, the anticipated quantity of people in the control room. Likewise, the studio, quantity of people, and general timbre of sound that the client wants. Now the shell has other functions, other requirements. Usually the shell is connected to and can be a major or a minor part of the acoustic isolation that the facility finally realizes. That is, containing the sounds that are generated within the rooms from getting out and retarding the exterior noise that would have a tendency to want to come in to any building. As being part of the isolation, the type of shell that's built can be numerous. The most common would be a concrete system, and when you speak of concrete, you can talk about hollow block, that is concrete infilled, steel reinforced, or you can talk about a concrete pour. These two things in concrete make up perhaps 80% of the kind of shells that most people would have built for them. And they perform an integral function as far as isolation is concerned from outside to in conjunction with the concrete wall, because it is extremely rigid and does not move in any way in response to sounds coming towards it. In conjunction with that isolation wall, many times there is yet an additional wood isolation system that would be built inside the control room and studio concrete walls. And the wood isolation system is usually a diaphragmatic type system, one that will move and respond to energy pressure, air motion pressure, whether it's from a live band or from a monitor system in the control room. Together, the concrete wall, the airspace between it and the wood wall, and the inner wood wall generally make up the total isolation of the facility from in-room to out-of-room. Some people may, there are many variations of this. You could say, okay, if it's on a common hallway, you don't want things banging into the concrete wall, which is the basic divider of the room. So you could add an additional brick wall in the hallway to buffer and protect the concrete wall so that there was no impact transmission directly imparted to it from any noise or things that might run into the wall if the wall was left unprotected in a common hallway. So in a situation like that, you'd have the protection wall of concrete on the hallway, you'd have a slab break, you'd have the concrete isolation wall on an isolated footing, you'd have an airspace, and then you would have the wood isolation system. The net yield of attenuation in decibels with respect to frequency will depend on the density of the concrete, the airspace that's involved between the wood and the concrete, and the diaphragmatic action of the wood system itself. All of this in conjunction will represent and vary the attenuation that will go from inside to outside. And in conjunction with that comes the concrete floor. You have a base slab, and you most generally will have a float slab, concrete, sitting on top of each other, divided by some isolation type of device. This can run anywhere from rock wool to very exotic spring systems that would separate the two slabs. And the wood wall would be built on the float slab. The concrete wall would be built on soil with the base slab not touching it. And the protection wall out in the hallway would be sitting on the hallway slab, which would be cut away from the studio. So that in reality you have a box within a box, a double isolation system, which is carried vertically up the walls and horizontally across the ceiling, sitting on the appropriate walls on the other side of the room and down back to the floor system again. Basically, that's what the shell is. There are, as I said, several ways to achieve an isolation shell, and what I've just described is one of the more common methods.
I don't know if you might answer this already. What is the primary engineering purpose of the shell, just as you described? Do you answer that? Or?
One of isolation and one of room square footage or square meters, whatever you're familiar with, of surface area on the floor, and that those proportions of width to length and height are good musical proportions.
we shut that off?
Yeah, just flip the switch to off.
There is coming to a little bit. That's still recording?
Yeah.
That's not a problem, just a problem.
Okay.
Before here. Once the shell is completed, we have to deal with the dynamics of the room. First, the control room. Take us through the process that you use to achieve the desired effects. The use of the hanging bats, the speakers, and the speakers that are surrounded by concrete, sound locks, etc.
Mm-hmm.
Okay, and as a follow-up, and also in the studio. Take us through the process and how does it differ from the control room in regards to the sound dynamics?
Mm-hmm.
As brief as possible.
Yes, right, of course.
Okay.
Okay. Last question first. How do the two rooms differ in dynamics? The sound pressure level in a control room will be limited and determined by the capability of the monitor system that's working within the control room. That monitor system can be anything from a bookshelf type of speaker system, which has a limit of perhaps 100, 105, 108 dB SPL, or perhaps as high as 130 dB SPL. Hence the dynamics, of course, are enormously different depending on the limitations of the monitor system. The bandwidth that comes out of the monitor system, the capable bandwidth from the monitor, has to be dealt with in terms of the room design and the half wavelength distance from the monitor to the back of the control room. All part of the dynamic question of a control room. Transient response, part of the same thing. The room has to be able to deal with the sound pressure level plus about 20 dB SPL for transient peaks. So that if you have a capability of 130 SPL from the monitor, you must design against a transient peak condition of 150 SPL if you truly don't want to have acoustic limiting on the sound that's coming out of those monitor systems at any level that they're capable of developing up to 130. On the studio side, it's quite a different animal and a much wider approach and wider capabilities of a studio noise generating component. If some band comes in with their Marshall stacks that they take on the road, set on a stage and play to 20,000 people, and they set it in your studio, well, it would fill some studio floors so there'd be no room for musicians. That's an extreme condition. Back that down to the guy that has just a simple little amplifier of 2 foot by 3 foot sitting on your floor. That's the other extreme. Somewhere between the ridiculous and the sublime will be reality. And that reality is going to be governed to some extent by the amount of surface area that you've got available for him to put his gear on. Then, once he does that, what are the sound pressure capabilities from that gear? Probably, in a small studio, the sound pressure capabilities from the guitar amplifiers will not be adequate to handle the sound pressure level that's capable from those amplifiers if he plays at full volume. It's hard to control the level of a band. It's hard to say to a musician, turn the amplifier down. But he can swamp your room, left unattended and left to his own will. Sometime if they want to just play louder and louder and louder, you can eventually swamp the room and you'll have nothing as a way of a recording that would be considered professional. The larger your room in cubic volume and the better designed it is from a trapping point of view and room basic proportions, which comes back to the shell design thing that we started with, the more capable that room will be of dealing with loud sound pressure levels. I have seen sound pressure levels in studios, I've measured sound pressure levels in studios of in excess of 135 dB SPL from some road stacks, quite beyond the capability of your human ear to handle without being damaged. And you walk into room situations like that, you better be wearing earphones or earplugs, unless you're satisfied with losing some hearing at the same time, because it is permanent. Once you lose it, you've lost that little portion, and you never get it back in life. So the dynamic requirement of a studio can be enormous because it's not something you can predict and control like you can a control room. And the only answer to it is build the largest cubic volume room and the best acoustic treatment that you can with respect to reverberation time that's required at the end of the job when it's finished from that room. Get the largest area you can, because that's where it starts, to be able to handle larger and larger sound pressure levels, which relate to the dynamic question. And if your room begins to saturate because the energy being generated is greater than the room can handle, you will have the effect of a compressor coming off that studio floor on every musical instrument. And what you've really got is well defined by the term acoustic compression. Room acoustic compression. So dynamics are important in a studio and much harder to control because you can't predict what the musician is going to do to you. The only advice I can say to the studio owner, potential studio owner, is get the largest studio area you can possibly get, even if you're only talking about 5-man band maximum. You might need a studio that's capable of sitting 100 musicians on the floor in a legitimate classical recording condition to be able to handle the sound pressure transients that is possible from a very loud 5-piece rock and roll band.
Okay, 5 here. Your design even takes the air conditioning system into account. How is the vibration and the sound from this equipment isolated?
Well, air conditioning has to be taken into account in a studio because it is a potential noise-producing animal. Air conditioning should be unnoticed, but should be there. Humidity control should be unnoticed, but should be natural and should be there. Your ability to hear it means that it's too loud. If it's turned on and suddenly you hear something in that environment, control room or studio, that you didn't hear when it wasn't on, then there's a defect in the design of the air conditioning and humidity control system as relates to your studio environment and your studio's noise floor readings without the air conditioning in the picture. Having said that, a good rule of thumb to have an air conditioning system designed against for a studio would be an absolute maximum of 20 dBA. This is well under the NC rating charts. There are no NC rating charts that will get down to those low numbers, but in the end, the acoustician should never see more than 20 dBA on any studio or control room with the air conditioning running, and 17, 18 is much preferred. What this implies is a very low velocity, large duct air supply and return. The mechanical vibration that you refer to in the beginning of your question is really one that is generated by an air compressor or a fan that's centrifugally out of balance in that compressor, or perhaps a compressor that's rocking up against the building and vibrating the structure. To start with, compressors should be outside, if possible, on the ground, on a separate slab from the building slab. And as the compressor output comes up to the wall of the building, it should go into an accordion type of a duct that would allow movement to be dissipated between one side, the compressor side, and the other side of the duct, which is the duct side that goes into the building. And that accordion device, we call it a bellows decoupler, that thing might be in size maybe a foot, 2 feet, perhaps, from one duct to the other. And it would, mechanical vibration on the duct system would be stopped at that point. And of course, then silencers are used on the duct systems in the ducts to reduce noise set up by the fan coils that could be inside the building along the duct system in some places. but in all cases the end result should represent velocities at the room intake and outtake of no more than 200 feet a minute. If that is the case in your room final performance, the likelihood of you achieving their 20 dBA noise floor with the system on are quite good. That's a very simplified answer to a very complex question.
Your design goes beyond just controlling the sound. What other components, such as amplifiers, wiring, studio monitors, etc., does your design include?
Okay, it's a kind of a control room related question. I would have to say that any mechanical object, a desk, console, tape machines if they're in the control room, sofas, chairs, relate to the character, or let's say the non-neutrality of the control room. They will introduce things of their own size that would be size related or wavelength related to the size of the device, be it a chair or a desk or whatever. We have to stop at some point. We are not people that sell furniture. We don't sell chairs, don't sell sofas. We don't really build equipment racks, but there are definite guidelines that we do put forward to the people. Where we do stop beyond design and construction, and we do carry it out to and inclusive of the monitor system, because the monitor is so much a part of the control room's acoustic performance. Let's say that if your monitor is a bad choice, it's a bad monitor, the room should allow that monitor to sound bad. If the monitor choice is a good choice and a good monitor, then the room should allow that monitor to sound good. The room should be neutral to the monitor, but because the monitor is what people will say, oh, I like the sound of that room, or I like the sound of that, they usually will look at the speaker and say that to themselves, that's a great sounding speaker. Well, it may be great on its own, standing out in the middle of an empty field with nothing around for 20 miles to affect it. But when you put it in a room, its character should remain to what it was unaffected outdoors. And if the room allows that to happen, then the room is well designed. The room and the monitor are two different animals, but yet they're married, and you can never divorce the two. What you do with one, you will affect the other, and vice versa. So we take it to that point. We design the room, we build the room, and we supply the monitor, we install the monitor. Because installation of that monitor source, the music source in the room, extremely important to the way that monitor will sound in the room. Probably the one most important thing in the control room, how that monitor is mounted and the selection of that monitor with respect to how the room will be recognized by the folks over the years when the room is done and working. We take it that far, but we should also say at this point and reiterate what we said earlier, that sofas, chairs, equipment racks, and any other extraneous things that are brought into the control room that are large in physical size will have an impact on the acoustic performance of the room that will be wavelength related on the low frequency side and reflective related on the mid and high frequency side of a control room listening environment.
Now that we have constructed the entire facility, show us where the sound comes from, how it travels through the room, and what happens when it hits the different surfaces and equipment. It says here use the blueprints, but we can't do that.
Well, really, the sound in a control room, that's again a control room related question. The sound in the control room, as we just said, comes from the monitor system. And the monitor system will present it to the room, and as we stated earlier, the room should be neutral. A neutral environment, an honest environment, would allow the sound to propagate into the room as air mass motion movement from the monitor at the front of the room to the rear of the room behind the engineer. And that pass should be unobstructed in an ideal situation. This would say that in ideal situations you have no console in your control room, you have no tape machines, you have no chairs, you just have a couple of people sitting on cushions in the middle of the floor. That's wonderful, but it's not workable. It's not the purpose of the room. So there is a compromise here. It's a fine line of what should be and what is allowable to still be within the realm of good sonic performance, so that when that mix is done and taken out on the street, it sounds good in a car radio, it sounds good at home, it sounds good down at the bar, it sounds good wherever you listen to it under different environments, because you've heard it correctly and you've mixed it correctly because the monitoring environment has been neutral. Sound starts from the front of the room and propagates to the back. That was your basic question. How does it get into the room and what handles it? As it goes on its way, in its journey to the back, it flies across many membranes that are hanging in the walls and in the ceilings, and it rolls along the floor, and low frequency does, on its journey to the back of the room. When it gets to the back of the room, ideal conditions, you would have a saw and you would saw off that back of the room from top to bottom, and you would let it exhaust out into the great Atlantic Ocean with never a reflection coming back. This would be ideal, but again, not usable. So what you build in the back of the room must severely attenuate the pressure that's coming towards the sides and back of the room. Attenuate it to the point that what is reflected back in is so reduced in power that it's overcome by the oncoming power from the monitor up at the front of the room as the monitor continues to play. This is the way that will allow you to have a room. This is the path that will lead you to a room that will allow you to walk around the room and not hear tonal balance changes as you move from the console to the rear of the room. And this is the ultimate function of a control room. To be honest to the guy that sits beside the engineer is one thing, but to be honest to the guy that sits 4, 5, 6, 8, 10 feet back from the engineer, it's quite again another thing. And if he can hear a good music mix that's essentially the same as what the engineer producer hears, you have a room that is linear. And that's the key. And the only way you get a linear room is you have a neutral room. And the only way you have a neutral room is to use the attenuators as required through the ceiling and the walls and the rear wall, side walls and rear wall, to deal with the sound once it gets in the room. I'd like to back up to one point. How it gets in the room from the monitor speaker is an interesting point. For years, we've built studios that had monitor systems built into a wall. It was a wood frame wall. And for years, we could walk up to these monitor walls, put our palm of the hand on it, and feel the low frequency vibration with every bass note that went by. And for years, we would wonder why that monitor system in sound pressure level readings in the room never resembled what that monitor system would do in an out-of-door condition. Obviously, the room mounting was damaging the monitor character, because after all, remember, if the framework that holds the monitor system in place is responding to low frequency pulse of the monitor box, then for sure there is sound that is kept in the framing rather than coming into the room. And it's kept into the framing at different frequencies depending on the size of the framing and the distance of wood run before it meets an adjoining wood structure that in turn reduces it a bit. Give it a 3-foot run, 6-foot, 12-foot run, it'll all be different as far as the fundamental wavelength that's stuck on that wood framing. Now, if it's there on the wood framing, it's not coming into the room audibly because the monitor system is energizing the monitor wall structurally while it's also trying to energize the air and come forward for you to hear it. So we found that if we were to build the monitor wall out of concrete, and it's a tricky construction, it's a wood-concrete combination, and surround the monitor box in concrete with wood framing outside of it, and it's a poured system, poured concrete system, that if we minimized the amount of vibration to the wood, effectively the wood framing is quieter with less motion than the monitor box sitting in concrete has at this point. So we've gone a little further than necessary, but in doing so, we found suddenly that the monitor system, as it plays in free air, measures in free air, measures the same way in the room. Well, the only way that's achieved is that you do not accept any vibration on the monitor wall whatsoever. It takes a very specialized type of construction to build that wall, to make it work so that whatever the monitor comes out of the monitor indeed becomes airborne frontal in the room, heading towards the engineer in the rear of the room, rather than staying on the structure frame. If you can achieve that, it's the most difficult part of the control room construction, you indeed will be on your first step towards getting everything out of the speaker into the room. Step number one. Then how you handle it in the room acoustically becomes a design criteria that's far too lengthy to get into in this interview.
Your design goes to great lengths to control the sound the engineer hears. Why is this so important?
That's where all the decisions are made. Final decisions are made there. And if the engineer producer agree on a certain character of sound, by God, that is what had better be there when they take it outdoors and play it on their car and at home and the A&R offices and various places that they go to present that record. That's what it better sound like. And the only way that's going to be achieved is through all the things we've talked about, how the monitor is mounted in a wall, how the traps are hung around the room, how they're hung in the ceiling. The whole balance of that room and monitor combination is what it's all about, is to make it neutral and honest at the engineer position, because that's where the final decision is made. If you give them an incorrect picture there, sonically an incorrect picture, they're going to incorrectly mix the record. They're going to take it out on the street and say, oh God, why so much bass? Look at that upper bass, look at the lower middles. How come it's so bitey? How come the top's so dead? How come this, how come that? Why? Because they didn't hear it right in the first place. And that's why the emphasis on control room design being such a particular fussy kind of design that allows that accuracy of monitoring and neutrality of sound character.
Considering the various elements which you bring together to create a studio, what makes your design unique and so in demand worldwide?
Demand worldwide repeatability of sound character from Tokyo to London. Why? Because of the very question we've just talked about. The engineer producer hears it the same way, and they'll hear it the same in Tokyo on the new designed rooms as they will in Nashville, New York, London, Paris, South Africa. Doesn't matter. That's what it's all about, consistency, and that's why the worldwide demand.
How has science, the science of studio design, changed over the years to bring us to this point? This would be a good time for you to tell us a little about yourself and how have you been designing rooms?
I think I was the first commercial acoustic design builder in the world. And I believe that this started in 1969 with the record plant in Los Angeles on 3rd Street. Westlake Audio was formed I formed Westlake in late 70, early 71. And our business was the design and construction of recording studios. And we started off with people like, as I said, the record plant, where I was working as maintenance engineer for Chris Stone and Gary Kelgren. And I think Westlake's first design and construction job was MGM Records in Los Angeles on Fairfax Avenue, which has now become Cherokee Recorders. Second job was for Amigo Studios in North Hollywood, which is still the Warner Brothers facility run by Lee Hirschberg. And I believe the third one was Caribou Ranch for Jim Guercio in Colorado, and so on. It started with a lot of experiment and a lot of ideas. To my knowledge, there were no books written on how to control sound within a room. Yet, having been a musician for a good number of years of my life, and been in and around music for years at that point, to today it's around 45, 47 years in the music business. But at that time, I knew that things weren't right in the control room, having once been a musician and sat on the other side of the glass and played horn. It didn't sound the same in a control room as it sounded on the studio floor. Why? And its studio design has gone from there, experiment, 2 steps forward, 1 back, sometimes 2 forward, 3 back, until we get to the point where we begin to get through our thick heads what makes things work and why. And that took about 200 studios of experimentation for me to finally cotton on to what was going on. In the interim, many other companies have joined. I believe Studio Supply in Nashville, about 1 year after I started Westlake, formed a company run by Dave Harrison at the time. They too began to design studios and install equipment, like Westlake. And then it grew and grew and grew. And I went to Europe in 1975 and introduced the design, as I had developed it up to Westlake at that point, into the European scene. And it was quickly accepted, and we built hundreds of studios in 76, 77, 78, 79, learning all the time. The new design concept came after that we're building now, came after I went into retirement. I left the business in late 79, early 80, and moved to Hawaii and retired. I was burnt out, tired, hundreds of studios behind me at that point, and a lot of experience, but my mind was really just fried, too much work. The last year of work was 1978, the last full year. We designed 50 studios in 52 weeks and built 35 of them in that calendar year. I was ready to die, physically. Chest pains, all the rest. So I said, oh, this is going nowhere, I have to stop. So I did. I just stopped for 6 years. During that 6-year period, some friends from Japan asked me to come over and talk to them about their studio, and I said, look, my crews are disbanded. I have no more material supply connections. I'm not in the business anymore. That's all right, just come. Be our guest. I said, okay, fine. So I was living in Honolulu. We got on a plane, went to Japan, and presented a very, very interesting proposal to me. This is a SETIC company for SETIC Studios in Tokyo, in the Roppongi area. And there I met Mr. Kinoshita, who designs and builds the monitors that we presently are using. Kinoshita said to me at that time in 1983, Tom, would you mind if I took the old Hidley monitor, which was the Westlake monitor, Eastlake monitor, and try to improve on it? Kinoshita worked for TAD at the time, and I said, please be my guest. He did, and he improved on it. Great deal. He took it from a 1969 design, which is when I first originated that monitor, up into the 90s, in one fell swoop in about 6 months. And I had been thinking about certain problems that bothered me a lot in the control rooms prior to 1980 that we had designed and built, particularly why the monitor didn't sound and didn't read the same as it did in an outdoor environment. And after a couple of years of retirement, laying on the beach, I came to 3 or 4 conclusions of things that I had done that were incorrect in the past and really should be tried by somebody new. Well, SETIC prevailed upon me, and I said, okay, fine. We're going to build 2 rooms, then great. We build 1 room, the old tried and true method. We build the other room, talking control rooms only now, employing 4 new concepts. And if you agree to do this and agree to correct the room that is wrong, sonically really wrong when it's done, because they'll be vastly different. If you agree to tear out the other room and rebuild it, then I'll agree to join you on the project. And they said, yes, of course. I said, okay, let's do it. So we put up one old conventional design, and we put one other design together that had 4 basic concept changes from the original old East Lake, West Lake designs. And the new one proved to be astounding. And they said, okay, so we take the other one down and rebuild it. I said, right. So they did. And at that point I was so excited about the sonic performance improvement that I decided this is worth bringing to the industry, which I did in 1986 by moving back to Europe and starting again with the new concept. Well, to put it mildly, around the world, a global rush to these rooms. I've never been busier. I've never advertised. My phone is unlisted. It's amazing. And what are they rushing to? Not something that looks pretty. Well, they're pretty rooms, not to take that away from them, but they're rushing to sonic performance that they've never heard before, and the musicians have said, and producers have said, my God, where? I've never heard such a thing before. How can this be? Non-believers converted into believers. As I've said to the clients, you get them into the room. Just get them into the room. The room will bring them back. And this is what happens. That's basically the history.
Next question is, where did you get your training? But I believe you answered that already. Basically.
In the field.
Okay. Is it true that Abbey Road Studio, made famous by the Beatles, was a Hidley design?
No.
Where are some of the other rooms located?
Which continent do you want to go to?
Just basic cities in Europe, I mean.
Oh, in Europe. Okay. London, Paris, Rome, Capri. The major centers, music and film production. We're working on both sides. We probably do more film work today than we do music record studios, maybe 60-40.
How similar the designs and purpose are your rooms worldwide?
Since 1986, with the new design concept, remarkably similar. The first 20 hertz control room that was introduced to the industry in 1986, Masterphonics Mix Room. Today, as we speak, that room is booked solid into June of '93. This is weekends included. That's a prototype room, 1986. Product taken from there to Nomus, a 1988 room in London, 20 hertz, or to Capri, a 1990 room, or to the Soviet Union, to Moscow, to Mosfilm, or to Bop Studios, South Africa. Product is interchangeable. The only difference that's taking place today with the newer rooms is that you can arrive at that defined mix even quicker. They're more precise, they're more analytical, as we're fine-tuning this design and build process.
I got 10 after, right?
5, 7 after.
Students interested in this field would have a lot of questions about your work. What do you think is the best way to get started in the field?
The best training in the field is field experience. Book training is fine, but in the end, it's what you hear that's going to make the difference, and you're only going to get that experience in the field. Where to tell you to go, how to go about it, tough question. Really a tough question I don't really know how to answer. I'm beginning to pull out of the industry. I'm going to drop back to 1 studio facility a year beginning 1994. My commitments are finished next year, but presently are online. Things are going to slow down for me. I want it that way, and I want to only stay with very interesting projects from there on. So I'm not the kind of person